guys! Welcome back to my channel. Today, I'm going to be showing you how to solve differential equations, specifically separable equations. So, I'm going to start off with an example to illustrate how we would solve for separable equations. So, say we have an example that looks something like this. So with separable equations, we are trying to separate dy and then dx on dy on one side and then dx on one side, and then we integrate it. We integrate both sides, and then that's how we basically solve for these separable equations. That's kind of like the plan. So separate dy and dx, so all the y's on one side and all the x's on the other side. It doesn't have to be y on the left side and the x on the right side. It could be the other way around, but the idea is the y's on isolated to one side and then x on the other side. So here, look at this question. We have dy over dx. Well, there's y here and there's an x here and there's an x here and a y here. So we're trying to get all the x's on one side and all the y's on one side. So here it's dy over dx. Let's recognize that with this, we can use exponent rules, right? Exponent laws. And we see 3 times e to the exponent of x, right? We're adding exponents. If we're adding, we can see that according to exponent laws, we can basically see that we are multiplying, right? Because this is the same base, multiplying by the same base, like that. Okay, so if we were to actually combine these, it would be x plus 2y, right? Because you're multiplying, you will have to add these exponents. So we get this, and now this will make it easier for us to separate the y's on one side and the x's on the other side. So here we have an x here and a y here. So let's rewrite this part first. And then here it's 3 times e to the exponent of x and e to the exponent of y to y. Now here we can see this is y and this is x, right? And we can basically multiply by dx on this side to this side, right, on both sides. And then we will have x on both sides. And this y is here, but we'll deal with that later. So let's do that first. So dy over dx. So we multiply by dx on this side. And here we also multiply by dx. And then once we do that, we can see that, okay, well, we just have this y right here, right, that we need to get rid of is, well, this is going to be dy, right? So we basically divide by e to the exponent of 2y just to move this y, right, 2y, this e to the exponent of 2y to the other side. So we're going to divide both sides by e to the exponent of 2y, right? So we can move this to the other side. So we copy this 3ex and then dx, right? This gets moved to the other side, like right here. So we divided it by e to the exponent of 2y, and that's how we got rid of it. Now we see, okay, well, we have all the y's on one side and all the x's on the other side. Now the plan is, as mentioned before, we have to integrate both sides. So we're going to put the integral sign on both sides, so just like this. This can be rewritten as 1 over e to the exponent of 2y dy, right? And so we can put the dy on, like, after it. And then here it's 3e to the exponent of x dx, just like that. And then what happens next is we see that, oh yeah, this is 3, we can bring this outside, right? So we could do that. And also here we can rewrite this with negative exponents, might make it easier to integrate. Negative 2y, right, because it's in the denominator. And then here, this is, we bring out the 3, so the integral of this. And then now we just have to integrate both sides. So we're going to focus on each side. So with this side, it's the integral of e to the exponent of negative 2y. Now, what we can do is we can use a substitution. So we can let u equal to negative 2y. So we can integrate this. And that will make du over dy equal to negative 2, just like that. And then we can see that we can see that we need to replace for dy, right? We're trying to replace this dy with some sort of du, so we're going to multiply by dy on this side. Du is equal to -2 dy, and then we isolate for this dy, right? So that's why I'm multiplying it. And then I divide both sides by -2, so du over -2 equals dy. dy is equal to du over -2. Just like that. So du over -2 can replace this dy right here. So, well, we also have to replace -2y, which is just u. So we're going to write in u here. And our dy in this case is du over -2. And then now we look at this and we see, oh, well, the integral of e to the exponent of x. Well, we know that if we have, say, a function y equals e to the exponent of x, the derivative is always going to be e to the exponent of x, right? So that's basically saying that if we integrate e to the exponent of x, like if we work backwards from here to here, right, we will get e to the exponent of x itself. So this is just going to be 3, and this times e to the exponent of x, because that's the integral. And we will have to add a constant c once we integrate both of these. We haven't integrated this yet, but I mean, we can add the constant c. We'll add it later. Yeah, we'll add it later once we integrate both sides. So this side still hasn't been integrated fully yet. So here we see this is -2, so we can bring this out. Side it's basically -1/2, and then this is e of u. du equals 3 times e to the exponent of x. And now we see that if we were to integrate e to the exponent of u, just like before I mentioned, the derivative is basically itself, so that would mean that we will basically get the same thing. So it's just e to the exponent of u. That's what we will get. And this is equal to 3 times e to the exponent of x. Well, since we got rid of the integral sign, let's add the constant c right now, because when you integrate, you need to have that constant c, very essential. And then we see here, well, this is u. Well, we have to make it back into our original variable, which is basically y, right? So we need to change this back to y. And to change it back to y, we have to recognize that u is equal to -2y. So this is -1/2 times e to the exponent of -2y, like that. And then this is 3 times e to the exponent of x plus c. So now we have our equation. However, we can see that it is not quite right because we haven't really isolated for y. So let's isolate for y. So we can see like an equation of this form, like y equals something, right? So let's do that. So to do that, we have to see that this is basically e to the exponent of 2y, but in the denominator. So I'm going to rewrite that, e to the exponent of 2y in the denominator, right? This is equal to 3 e to the exponent of x plus c. So here we can see that we can multiply this denominator with this side, so to make it easier for ourselves to isolate for y. So we're going to do that. So multiply it on this side as well. Now what we can do is we want to get rid of these x's, right? This x term, well, it's with the c, so let's divide both sides. -1 over 3 times e to the exponent of x plus c is equal to 2 times e to the exponent of 2y, like that. Now we can see that we just have this stuff left, right? Let's divide by 2 on both sides. That will help us. Divide by 2 to get rid of this 2, right? And now it's a lot more simpler. Now we want to get rid of this e to the exponent of 2 and all that. So now the trick is we have to take the ln of both sides. So take the ln of both sides. So in the meantime, I'm going to expand this. So it's going to be 2 times 3 is 6, right? E to the exponent of x, right? And then plus 2c. Well, technically, if we do 2c, let's just let 2c equals c1. Okay, so this is just going to be c1. It doesn't really matter. Constant is just the constant, right? So this is going to be 2c, right? Because if you multiply this, it's going to be 2c. It's just going to be c1 because we just let that happen. and then we have e to the exponent of 2y here, and we have to ln this side as well. And when we ln something like this and we see 2y here, we can take this 2y at the front. It's just going to be 2y times ln e, and then here we have ln, and we can simplify. I mean, we can make this fraction a little bit more simpler. So we can recognize that this is a reciprocal, so it's like to the exponent of -1, right? It's like this whole thing, at the denominator, to the exponent of -1 right here. So 6ex plus c1, right? To the exponent of -1, just like that, because it's in the denominator, and we can't forget this negative here because of the -1 like that. So it's being multiplied to the denominator, right? I mean, divide, because like you're dividing it by this whole thing, but if you change it to multiplication, you have to make, if you want to move it up to the numerator, you have to change it to -1 as the exponent, like that. So this ln e is just going to be 1, okay? And so we have, ultimately, here we have ln -6ex plus c1, I'm just going to rewrite this, make it look neater, equals 2y, and we can basically divide both sides by 2. So we can isolate for this y. So divide both sides by 2, and then this is going to make y equal to 1/2 ln of -6ex plus c1 to the exponent of -1. And why did we change this to -1? Well, we see here it says -1, right? We can also apply it to this negative right here. So we can basically say that this is equal to 1/2 ln -1 right here, right? This is -1. And this -1 is to the exponent of -1 as well. And this is 6e to the exponent of x plus c1, like that. This is to the exponent of -1 as well. Because, well, this is not going to change anything if we do if we apply this -1, exponent of -1 to this -1 as well. Well, it's not coming from here, but we're trying to make it we're trying to manipulate this so we can change the whole thing to the exponent of -1. And that's because if we look at -1, right, it's equal to 1 over -1, right? This is the same thing. And then this is basically equal to -1 to the exponent of -1 right here, because this is in the denominator. So that would mean that here, according to exponent rules, we can combine those together. So 1/2 ln, and this is just -1, this is just -1 times 6ex plus c1, right? All of this is going to be put into brackets to the exponent of -1, right? And then we see here, well, we can basically use ln laws, right, to our advantage here. So we know ln x to the exponent of b is equal to b times ln x. And in this case, when we have this, we can basically use this to our advantage, and our b in this case is going to be equal to -1, as shown here. So we can take this out and bring it out of the ln. So we can bring this out of the ln right here, and this is going to be a -1 times 1/2, so it's going to be -1/2 ln, and then here, whatever that is inside the brackets, -1 times 6ex plus c1, just like that. And then we could distribute this to each of the terms. So we're going to get -1/2 ln -6ex minus c1, just like that. And there we have it. This is our equation. That answers the question for solving this differential equation. And this brings me to the end of the video. If you enjoyed this video, feel free to give it a big thumbs up, and Let me know in the comments down below on your thoughts about separable equations. And also, if you haven't done so yet, feel free to subscribe to my channel if you enjoy my content. Thank you so much for joining me today on this math video, and I hope to see you next time in another one of my math videos. Have a nice day. Bye!